Now we're going to take up a version of modulation. Modulation means changing a signal in some way. In this case, we're talking about spreading a transmission out across multiple frequencies. We call that spread spectrum. And by spreading it out across multiple frequencies, we can get more data because we get a little bit of data on this frequency and a little bit on this one and a little bit on this one and so forth. And we have three types. And I'm not going to go into great detail with these, but I'll give you kind of a basic, quick look at what they look like. And they do get more complicated as we go down, but they get better as we go down. First, we have FHSS, Frequency Hopping Spread Spectrum. All we're doing is jumping around. One frame goes on one frequency, another frame on another frequency, and so on. Like a player piano scroll, right? Or just even like playing the piano. You have a whole bunch of keys, and the first note, say the first quarter note goes on one note, and then another quarter note on another note, and another quarter note on another note, and then you put it all back together. That's kind of what frequency hopping spread spectrum is. I'm going to show you a visual on this in just a minute, but let's talk about the others first. DSSS is direct sequence spread spectrum. So in this case, each bit is actually encoded into 8 or 11 bits. So yes, it's going to take 8 or 11 bits to represent a single bit. Now that doesn't sound like it makes sense, but all 8 of those then, or 11 of those, are sent across on different frequencies, and then they're reconstructed at the receiver. And because of the capability of reconstructing it so easily and not having to retransmit data, it's actually faster. And then finally, the most complex one, orthogonal frequency division multiplexing. Now, frequency division multiplexing is something like what we were just talking about a minute ago with FHSS. If I use multiple frequencies and I can transmit a signal down this frequency and another signal down another frequency, then I can send 2 signals at a time. But now we have this tricky word orthogonal, and I'll explain that in a moment. But frames are sent simultaneously over multiple frequencies, and the frequencies are calculated to overlap in a way so as to not to interfere with each other. Now let's take a look at those charts. Here's FHSS, frequency hopping spread spectrum. One frame goes down one frequency, another one down another frequency, and we just keep jumping around just like a player piano roll. In DSSS, we have a bit, let's say a 1, and we take that and do a mathematical calculation to turn it into a series of 11 ones and zeros. Now, how we do that, I'm not going to get into right now. We generate a random number, and then we do an exclusive OR, okay, whatever. Then we take all of those and we transmit each of them across a different frequency. So this 0 is up here, this 0 is here, this 1 is over here, and so on. And we transmit these across all different frequencies. They're received at the other end, and they're put back together to make a 1 again. I know it doesn't make sense. How can this be faster than just this? Trust me, it is. And it is because of the number of times that we have to keep resending frames whenever we're missing a 1 or a 0. And by doing this, we don't miss them as often, so it makes it actually faster. Finally, the OFDM, orthogonal frequency division multiplexing. We have several different frequencies, but we have mathematically designed them in such a way that they always cross here at the 0 point at the same time. And by doing that, they don't interfere with each other. And so even though these frequencies are very close together, you see the purple one and the red one here are very close together and should interfere with each other. But because they've been mathematically designed here to be at harmonics of one another, then they don't interfere with each other. Again, kind of complex. I'm not going to get into the math of it because it's very complicated math, but that's how these three things work. And as we added these things as well as MIMO, we went from FHSS early on to DSSS and then to OFDM and then MIMO OFDM and then 8-bit MIMO or 8 antenna MIMO OFDM. As well as the higher bandwidths, you can see we're getting faster and faster and faster data rates.